Hey everybody, in today's lesson from Unit 3.1, we're going to learn how to solve application problems using our sine, cosine, and tangent functions. First of all, we need to learn a little bit about something called an angle of elevation and an angle of depression. An angle of elevation is the angle that an observer would raise their line of sight above a horizontal line in order to see an object. For example, if you were to look straight ahead, so say you're standing here on the ground, okay, you're looking straight ahead at a building. So this would be a horizontal line looking straight ahead at a point on the building. Then if you changed your gaze so that you look to the top of the building, this angle right here would be an angle of elevation. Okay, so think of an angle of elevation looking straight forward, then looking up. An angle of depression happens if an observer were up above and needed to look down. The angle of depression would be the angle that the person would need to lower their line of sight. For example, if you're on an observation tower, think of the tower over on Route 1. So here's our tower. Okay, and this person's standing up here. If they were to look straight ahead, and then if they were to change their line of sight, so they're looking at an object on the ground, this angle formed by that change in their line of sight would be an angle of depression. Okay, we're going to take a look at some pictures and determine, we're going to name the angle of elevation and the angle of depression in each picture. Okay, so in this first picture, we've got an airplane, we've got a little fisherman in a boat. From the perspective of the fisherman in the boat, looking up to the airplane, this angle, angle GEF, would be an angle of elevation. Now, if you're a person in the plane looking down to the boat, then this angle, angle HFE, would be an angle of depression. Now, there's something important to note about angle of elevation and angle of depression. Okay, we heard me mention about looking out towards the horizon. These two lines are horizontal, so they're parallel to each other. And this line, that line of sight for both the person in the boat looking at the plane and for the person in the plane looking at the boat, that's our transversal. And when we have two parallel lines cut by a transversal, we have alternate interior angles that are congruent. So these two angles are congruent to each other. And now that's really important. It's going to help us later in our word problems. Okay, in the second example, from the perspective of the person flying the kite, they have the angle down at his feet, but that would be an angle of elevation, so angle KHJ is an angle of elevation. Okay, and if you're up at the kite, looking down towards that person, angle IJH would be an angle of depression. So depression means looking down towards the ground. Okay. In the next picture, we've got a little person on a sled. So if he's at the top of the hill, he looks straight out towards the horizon, then he looks down to the bottom of the hill where his friends are. That's an angle of depression. So angle TSU would be the angle of depression. And one of his buddies at the bottom of the hill, looking up towards him, would look up through an angle of elevation, so angle RUS. Sorry about that. And we want angle of depression. And angle RUS is the angle of elevation. Okay, one last one. Okay, if you're at the tower and you're keeping watch, looking out for a fire, okay, if you look straight out towards the horizon, then look down when you spot this fire down below, then angle ATF would be your angle of depression. And if you're a firefighter here on the ground looking up towards the tower, then this would be an angle of elevation, and that angle is angle BFT. Next, we're going to solve some problems involving these angles of elevation and angles of depression, and also involving trig. So you're definitely going to need a calculator for this. So it says for each problem, draw a diagram, write a trig equation, and solve for the missing values. Round any lengths to the nearest tenth and any angles to the nearest whole degree. Sometimes the trickiest part about these problems is coming up with a diagram. So number 5, it says, driving along a straight, flat stretch of Route 1, you spot a hawk in a tree right next to a mile marker. So we've got this bird in a tree, okay? And it says, watching your odometer, you pull over exactly 2/10 of a mile down the road. So in your little car, you pull over 2/10 of a mile down the road. Okay. Now it says, you determine the angle of elevation from your position to the hawk as 2.4 degrees. So angle of elevation would be from your position looking up to the hawk in the tree, 2.4 degrees. It says you are trying to figure out how high in the tree the hawk is. Right. Now, we're trying to solve for this height, x. We're going to assume that the tree is perpendicular to the ground, so we've got a right triangle. Now we can use trig. So if we take a look at our angle, if you go across from the angle, x is labeled as the opposite side. The 0.2 miles, that distance, is the adjacent side, so we need to work with a tangent function. So tangent of our angle, 2.4, is equal to opposite side x over adjacent side 0.2. Now, we're going to convert this to feet. In the end, we're given a little clue here that 1 mile equals 5,280 feet. You could do it now, but I'm going to choose to do it at the end of the problem. Okay, to solve our tangent function, write it as a proportion. So put this over 1 and then cross multiply. So take x times 1, you get x. Take 0.2 times the tangent of 2.4. You're going to go to your calculator with that. You should come up with 0.008, but that's in miles. Okay, to convert it to feet, you're going to take 0.008 times 5280, because they're 5,280 feet in a mile. When you do that, we're going to come up with approximately 44 feet. And don't forget, our directions did ask us to round lengths to the nearest tenth, so we're going to say 44.3 feet. Okay, in question number 6, it says, from the top of a lighthouse, 210 feet high, a boat is spotted. So if we just take a second and draw our lighthouse. Okay, and there's the ocean, and we've got this little boat. Okay, so the lighthouse is 210 feet high, and the person that is on the lighthouse first looks out to the horizon and then looks down to the boat. It says the angle of depression to the boat is 27 degrees. Now that's from the perspective of somebody on the top of the lighthouse. If you are on the boat looking up at the lighthouse, the angle of elevation would be 27 degrees. Now this is really important. We need to get this triangle, this right triangle, and we need to have this angle inside the triangle so that we could use trig. And remember, the angle of depression from somebody looking down to an object is equal to the angle of elevation from somebody down below looking up. Again, we're going to assume this triangle is a right triangle. And it says, knowing that the lighthouse sits at sea level, find the distance from the base of the lighthouse to the boat. So we're looking for this distance. Okay. So in a much simpler diagram, this is what we've got. 27 degrees, a distance x, okay, right angle, and a height of 210 feet. Okay, so if we take a look at that diagram, we're still going to work with tangent. We're going to say the tangent of 27 is equal to 210 over x. Okay, we're going to cross multiply. We get x times the tangent of 27 equals 210. And then take and divide both sides by the tangent of 27. So when you divide this out, you go to your calculator and do 210 divided by the tangent of 27. And you get 412.1 feet. Again, rounding to the nearest tenth for distances. For our very last question, it says an airplane rises vertically 1,000 feet over a horizontal distance of 1 mile. What is the angle of elevation of the airplane's path? Okay, so if this is the ground, and our plane is going to be taking a path that rises vertically 1,000 feet over a horizontal distance of 1 mile. So this would be the horizontal distance, 1 mile. Remember that 1 mile is equal to 5,280 feet. We have to have the same unit of measure for both distances. Okay, so a vertical line is perpendicular to a horizontal line. That gives us our right angle. And this is our plane up here. Okay, no, it's not a very good plane, but it's our plane nonetheless. All right, we want to know the angle of elevation of the airplane's path. So we're looking for this angle right here. All right, so for that angle, 1,000 feet is the opposite side, 5,280 feet is the adjacent side. So again, we're going to be working with tangent. So say tangent of x, our angle, is equal to 1,000 divided by 5,280. So our angle x can be found by using the inverse tangent and then typing in 1,000 divided by 5,280. You could reduce that beforehand if you wanted to, but there's really no need to. Okay, go to your calculator, and when you do that, you should get an answer of 11 degrees once you round it to the nearest whole degree. Okay, so degrees, for the angle measures, we want rounded to the nearest degree. Distances, round to the nearest tenth.